Hello guys, welcome to my tutorial class on solving polygon. In this section, I'll be working on GCSE, IGCSE, IB, PSAT, and AISL exam style question. So let's take a look at the first question now. Calculate the sum of the interior angles of polygon with these numbers. Guys, because I have a lot of questions to solve, so I will just solve one of this option and you apply the same method to any of the remaining questions. So let me go with the one with the IS side. This is 100 stuff. Okay, so now let's get started now. Okay, now guys, don't forget that generally to the sum of interior angle of any given polygon is n minus 2 times 180 degree. Okay, so n minus 2 times 180 degree. Okay, so now so where n is the number of side. Okay, so the sum of interior angles for polygon with 100 side will be n is 100 minus 2 times 180 degree. So that will be 98 times 180 degree. So guys, you can take your calculator now to complete the task. Okay, so let me do that now. So 98 times 180, so 180 times 98, so that gives 17,640. So 17,640 degree. So guys, I have a lot of questions to solve and because of our time, okay, so I'll just solve one out of all the options. Okay, so don't forget, if you have to find the sum of interior angle in a polygon with 10 sides, then just substitute 10 here. So you place n with 10. For 15, that will be 15 minus 2. For 45 minus 2, and you get your answer accordingly. So that's a solution to the first question. Let's take a look at the second question. Okay, so the second question says calculate the size of the interior angle of regular polygon with this number of sides. Okay, this time around we want to calculate the size of the interior angle. So this one is each interior angle. The first question was the sum of the interior angle, but this one we just need one of the interior angle, or better still, each of the interior angle. Okay, so calculate the size of the interior angle of a regular polygon with this number of sides. Okay, so the size of the interior angle, not the sum this time around. So now guys, each interior angle of a regular polygon, since the sum is n minus 2 times 180, the sum, this is the formula for the sum, don't forget, just as we have in the first question here. Now but this one, each interior angle will be divided by the total number of sides. Okay guys, this time around, let me go for the smallest side, which is 9. The first question I went for the highest number of side, but this one let me go for the least number of side, 9. Okay, so don't forget this is for each interior, but n minus 2 times 1, this is the sum of the interiors. Okay, so now for 9, that will be 9 minus 2 times 180 degree. 9 minus 2 times 180 degree. So and that will give you the sum. Then to get each interior angle, then you divide the sum by n. So that will be 7 times 180 divided by n. Okay, now and the number of sides we are dealing with here is 9. So divide by 9. So guys, go ahead and use your calculator to complete the task. I'm going to do the same here. So I have 7 times 180 degree, and that gives 1,260. So 1,260 divided by 9. Do I need to write that? Okay, 1,260 then divided by 9. So 1,260 divided by 9 gives what? That is 140 degree. So by implication, each interior angle is in a 9-sided polygon is 140 degree. So let's go to the next question. So the next question says that find the number of sides of polygon with this interior angle sums. Okay, so we are given interior angle sums here, and we have to find n. That is, we have to determine the number of sides. Okay, this time around again, let me go with the IS. Okay, let me go midway now. First question, highest list, then let me go midway. Let's just work with 2340. So so if the sum, if the interior sum of the regular polygon is 2000, then we want to know the number of sides. Okay guys, don't forget the sum for any given polygon. The sum of the angles, the interior sum, is n minus 2 times 180 degree. So you use your formula now. So if you use n minus 2 times 180 degree, you should get the sum. Now, but this time around, the sum is given to be what? 2340. So 2340, because we have to determine the number of sides. So you use n subject of formula in this case. Now, since you want to use n subject of formula, then you retain this on the left hand side. So we are going to divide both sides by 180. Okay, so I have n minus 2 will now give me 2340 divided by 180. Okay, so I need to use my calculator to complete that first before I go ahead with the next term. So 2340 divided by 180, so that gives me 13. Okay, so n minus, therefore n minus 2 equals to 13. So you make any subject of formula, if you move minus 2 there, that gives you plus. So 13 plus 2, that is 15. So the number of side is 15. Okay, so let's go to the next question. Question 4. Find the number of sides of regular polygon with these exterior angles. So this time around, we are given exterior angles. Okay, number of side. Okay, now guys, find the number of side of regular polygon with these exterior angles. Okay, generally in any given polygon, the sum of the exterior angle is 360. Any given polygon, again, let me repeat that. The sum of, for any given polygon, the sum of exterior, let me put it there again, the sum of exterior angles is 360. Now, but if you want each exterior angle, that will be divided by n, just like you have in interior. Okay, now, so this is each exterior now. So now this time around, let me work with can I go with the least value this time around? Or let me just go random. Let me go with 15. So now find the number of sides of regular polygon with this exterior angle. So if the exterior angle is 15, so what is n? So then you equate that, because each exterior is 360 divided by n. So equate this one to 15. So if you want to find for 24, then equate it to 24, equate this one to 10, or this one to 5. But I just want to go with this. So if you cross multiply, guys, cross multiply now, you know what it means to cross multiply. This will be 1 times 360, then n times 15. So we have 15n equals to 360. Okay, 15n equals to 360. So what do you do to both sides? You divide both sides by 15. So divide both sides by 15, then you get your n. So I'm going to use calculator to complete that. So 360 divided by 15, 1, 5, 15, 24. So by implication, each exterior angle of a polygon with exterior angle 15 is number of sides is 24. Not degree, guys. This number of sides, I'm sorry about it. So it has 24 sides. 24 sides. So a polygon with this 24 sides. Okay, so let's go to the next question. Okay, question 5 now. Find the number of sides of a regular polygon with this interior angle. So this time around now, we want to find number of sides of polygon with with a given interior angle. So since it's interior angle, then you go with your sum first, n minus 2 times 180, and don't forget to put this one in brackets. Okay, so times 180, this will give you the sum of interior angle. But if you want each interior angle, that will be divided by n. So this one says I find the number of sides, so we are looking for n. So divided by n, because we are giving interior angle. So which interior angle can we go with now? Let me work with 150. Let me work with 150. So guys, go ahead and solve the remaining one. You can work with 140. Just follow this step, guys. Okay, so equals to 150 now. So cross multiply. So if you cross multiply now, you're going to have to the right hand side 150n. Then I can use 180 to open up this bracket. So 180 times n, that will be 180n, 180n minus 360 equals 150n. Guys, because I'm looking for n should be on the left hand side. So I'm going to take this one back there. So therefore I have 180n minus 150n. Then minus 360. If you take it to the other side, that will give what? Plus 360. So equals to 360. So 180 minus 150, that is 30. I'm going to complete the tax here now. Okay, so 180 minus 150, that is 30. So 30n equals to 360. Then what do you do to both sides? You divide both sides by 30. So n will be 360 divided by 30, and that will be what? 1, 2. So the number of sides is 12. Guys, hope that is clear. Just use your calculator to complete it. Just do 360 divided by 30. So that's 12. So next question. Question 6. Okay, guys, I will just solve one of these and then let's just take a look at this. And guys, you follow the same step, guys, because you have just unknown variable, just a single unknown variable here, e, c, or better still a. So but the same method, guys, I'll work with this one here. Let me just quickly call your attention to something. So the question says that calculate the size of the unknown angles in each of these polygons. So what you have to do, let me just tell you what to do now. If the number of sides we have here, 1, 2, 3, 4, 5, 6, 7, 8. So number of sides here, here is 8. For this one, n is what? 1, 2, 3, 4, 5, 6. N is 6. But I want to work with when n is 4 because I have a lot of questions, guys, to solve. So the same method. So the only thing you are just going to do is to replace the n value. And that's what I'm going to do now. So now the first thing here is to calculate the sum. Okay, the sum of the interior angle. Okay, so the sum of, to calculate sum of interior angle for any given polygon, the formula is n minus 2 times 180. N minus 2 times 180. So when n is 4, that will be 4 minus 2 times 180. When n is 6, that will be 6 minus 2 times 180. When n is 8, that will be 8 minus 2 times 180. Don't forget, I'm going to work with 4. So 4 minus 2 times 180 will give me the sum there. Okay, so just keep this one here. Okay, next. You now work with this now. So when you sum this, then it should equal to this. Let me just complete this task. 4 minus 2 is 2. 2 times 180 is 360. So guys, the same way, just go ahead and substitute for the value of n when n is 6, when n is 8, and get the corresponding sum. Okay, interior sum. Okay, so this 360 now. So by implication, when I sum all this angle here, it should be equal to 360. So I now have 95 plus 70 plus 65. These are angles are in degree. Then plus the unknown angle, that is A. So equals to 360. So if you want to work with this, just work 105 plus 100 plus 140 plus 160 plus 120 plus B equals to that will be 5, something like that. Okay, so let me just go ahead and use calculator to complete that now. So I have 95 plus 70 plus 65. So that is 230. So I have 230 and 230 plus A, 230 plus A equals to 360. So then you move that one there. So that nice. Okay, equals to 360. So move 230 there, then therefore A will be 360 minus 230. So 360 minus 230, 360 minus 230. That is 130 degree. So the value of A is 130 degree. So you go ahead and do the same thing for the remaining question. Then question 7. And guys, the same method here, but I have a lot of questions to solve. I don't know. Let me just go ahead and solve anyway. So because of our time, and I have a lot of questions to solve, much more demanding question down there. So let me just work with this. You follow the same step to complete either of these. Okay, now find the value of x in each of these polygon. The same way here. This is four-sided, n is 4 here. So the only difference between that question 6 and question 7 here is that here I have variables. So you just work with it too instead of constants. So and the first thing is to find the sum, okay, of angles there. So that would be n minus 2 times 180. So when n is 4, so that will be 4 minus 2 times 180. That is 2 times 180, and that gives 360. So the next step is sum all the angles now. So 2x plus this one now, x plus 20. Then plus the next angle, which is 2x plus 5. Then finally plus the last angle, which is 85. Then you equate it to your sum, which is 360. So I'll work with all the variable first. 2x plus x, that is 3x. 3x plus 2x, that is 5x. So I have 5x. Then sum all the constants. 85 plus 5, that is 90. 90 plus 20, that is 110. Equals to 360. So this time around, you make x subject of formula. So 5x, that will be 360 minus 110. So let me just use my calculator to do that. 360 minus 110, and that is 250. So you divide both sides by 5. So you divide both sides by 5, then x will be what? That will be 50. We are asked to find the value of x, guys. Sometimes the examiner can ask you to find the value of 2x, then that will be 2 times 50. Then if you have to find the value of x plus 20, that will be 50 plus 20, that will be 70. So we can go to the next question now. Okay, question 8 now. So question 8 says that what is the name of the regular polygon in which the interior angle are twice its exterior angle? So guys, this time around we want to relate the formula for interior and exterior angle. Okay, so now, but this one says that you have to be careful and read very well, in which the interior angle are twice. So this has nothing to do with is this the sum of the interior or each interior angle? So that's what they're talking about, which the interior angles are twice the exterior angles. So guys, don't forget, in a regular polygon, the sum of angles in a regular polygon is n minus 2 times 180. That will give you the sum. Okay, similarly, in any regular polygon, the exterior angle, the sum is 360. The sum. This is sum now. Now, but you are working with each angle now, because what's the name of the regular polygon? I need a regular polygon which the interior angles are twice its exterior angles. So if you want each interior angle, if you want to relate each interior angle and exterior angle, then you divide by n. So divide by n divided by n. So you know how to get it. Okay. Now, but this is not what the question is telling us. The question says that the interior angle is twice the exterior. So mean that this one should be twice this. This one should be twice this. So either way, if you like, you can work with n minus 2 times 1 is equals to 360. Maybe you need not to divide by n, but so that's it. So twice means that I should multiply this one by 2. So I can now complete my task now. Okay, guys, don't forget that this is irrelevant. This n is not necessary because I can actually work with n minus 2 times 1 is equals to 360 because this one says interior angles. So I can work with some, and then I can work with each. But either way, I'm cool. So let me just continue now. So n minus 2. Let me just open up the bracket so that I don't waste much time because I don't have enough space there. Let me just open up the bracket now. So by implication, so 180, I want to use 180 to multiply this now out now. So I have 180n minus 180 times 2, that is 360, divided by n equals to, and 360 times 2, guys, that is 720. You can use your calculator to confirm. 360 times 2 is 720. 720 divided by n. So you see that this n is common. So you can cancel it out and continue your solution here. So then I want to use my unknown should be on the left hand side, so I have 180n equals to, if I move 360 there, that will be plus, so I have 720 plus 360, so 720 plus 360, that gives me 1080. So my n you divide through by 180, so 1080 divided by 180, and that gives me what, 6. So the implication is that the type of polygon in which the interior angle is twice the exterior angle is six-sided polygon, and the six-sided polygon is hexagon. Can we confirm that, guys? Let's confirm that. Hexagon. Let's confirm each interior angle in hexagon is what? That will be 6 minus 2 times 180. 6 minus 2 is 4. 4 times 180. 4 times 180 is 720. 720 divided by 6, that is 120. So in an hexagon, each interior angle is 120. We are not asked to do this, I just want to prove it. Then for exterior angle, since it's an hexagon, that will be 360 divided by 6. 360 divided by 6 is 60. So do you see that it's times 2? So it's correct. So let's go to the next question now. Wesley measured all interior angles. Wesley measured all the interior angles in a polygon. He added them up to make 991 degree, but he has missed out one angle. What type of polygon did Wesley measure? Okay, so let's start with question A. Now, guys, don't forget, I need to call your attention to this. Let's go ahead with a particular polygon. Let me just go with a 1, 2, 3, 4, 5. Okay, let me go with 5-sided polygon. Guys, not to scale. So this is a regular polygon, not to scale. Okay. So now, how many triangles can I get from this in a pentagon, 5-sided polygon? The number of triangles is, how many triangles now? So 3 triangles. 1, 2, 3. So by implication, n minus 2. The number of triangles in any given polygon is n minus 2. Numbers of triangles. Numbers of triangles. And don't forget that the sum of angles in a triangle is what? 180. So this is another method. This is a very good concept for you to work with. Okay, now I'm going to do that, meaning that in a given polygon, in any given polygon, the sum of any given polygon will be product of when you use product of 180, that is 180 times n, where n is a counting number or positive integer, where n belongs to set of counting number or positive integer. So meaning that I can't have any, it must be product of 180. So for example, the sum of angles in a in a quadrilateral will be 180 times 2, because quadrilateral we are going to have 2 triangles there, 4 minus 2, so that will be 360. Okay, now this now is 991. So let's take a look at this now. 991. So let me just I can't start with n equals to 1 because that is going to waste my time. So let me just start with when n equals to 5, when n equals to 6, when n equals to 7, when n equals to 8 by deduction, and so on and so forth. So let's take a look at that now. When n equals to 5, I'm going to have 5 times 180. 5 times 180 will give me what? 900. Very close. So this is very close now. So when n is 5, my answer is very close to this because I have 900 here. When n is 5, the sum will be 900. So meaning that in 900, am I correct? Yeah, 900. So and 5 is pentagon. So the sum of angles in a regular pentagon is 900. And this is 991. So let me go with when n equals to 6 now. So when n equals to 6, that will be 6 times 180. And that is 1080. That is above. So this is what we should be taking a look at, because you can't work with something below, because the examiner, we are told by the examiner that that Wesley actually missed up a given angle, a particular angle, miss out one of the angles. So meaning that the sum should be more than 991. So and the next possible sum is 1080. That is when n equals to 6. So when n equals to 6, sum is 1080. So we can work with 1080 now, guys. So now what we are now going to do now is n is actually 6. I think we don't need to waste our time there because it's 1080. So because it should be more than 111. So what type of polygon did Wesley measure? So the name of the polygon is 6-sided polygon. So that is hexagon. So a 6-sided polygon. A 6-sided polygon. And the name of a 6-sided polygon is what? Hexagon. Hexagon. Okay, so what is the missing angle now? So the missing angle will just be 1080 minus 991. And that is what? So minus 991. That is 89. So the missing angle is 89 degrees. So let's go to the next question. In the triangle ABC, angle A is 42 and so on. Okay, so let's just go ahead and solve this problem. Now the question says that we should calculate the value of C. So don't forget that the sum of angles in triangle is 180. I don't need to, if you still want to work with polygon here, that's not a bad one anyway. Let's just go ahead and do the same. So n minus 2 times 180. That would give us the sum of the angles in the triangle. So but the triangle is three-sided polygon. So that will be 3 minus 2. That's 1 times 180. That is 180. So next, then I should have, let's see angle C, and let's just leave it as C. So C plus 67 plus 42, and should sum up to what? 180. So therefore, C will be equals to 180 minus the sum of 42 and 67. So 67 plus 42, and that is 109. So minus 109. So C is what? 180 minus 109. 180 and minus 109. That is 71. So the value of C there is 71 degree. So this one here is 71 degree. So next, what is the value of the exterior angle? Don't forget that the sum of on the straight, when you have angle, the sum of angle on the straight line is 180. Let me record that again. Sum of angles on a straight line is 180, and this is 71. So let's take this place to be x. So therefore x plus 71 should sum up to what? 180. And the reason is angle sum on a straight line is 180. So therefore x will be 180 minus 71. So you can use your calculator to complete that, guys. 180 minus 71, and that gives 109. So the exterior angle there is 109. What connect the exterior angle at C with the sum of interior angle AB? Yes, guys, don't forget this rule here. In intercept theorem, and there's a rule in intercept theorem that says that the exterior angle of a triangle equals sum of the two opposite interior angle of the two opposite interior angle. So that rule is in intercept theorem. So now if I want to, another way I can find x is, so if I want to go that way, and I should get 109 too, guys. So what connects the exterior angle at the sum? So this is the rule that connect them. So now let me just do that again now. So to x should be what? The two opposite interior angle. Now let me change this marker to blue now. So the two opposite interior angle are this and this. So that x should be sum of this. So now let's now go ahead with that. So we can also x in another form. We can find x by working accordingly. 67 plus 42, and that should sum up to what? 109. Guys, you can confirm with your calculator. That should give me 109. Let me confirm that. 67 plus 42. 67 plus 42. Correct. So that is what connects exterior angle and interior. So exterior equals to the sum of the two opposite interior angle. So question 11. So now this question here says two regular pentagon are placed together. Work out the value of A. Now guys, there are a lot of ways you can use to complete this task, but I will go the simplest way. The best thing for me to do is, since this is a regular polygon, thank God it's a regular polygon. So by implication, it means that each angles are the same. All the angles are the same. So if this were to be C, then the remaining angle too will be C. And the same thing is applicable to this one here. So everything there is C. So I think everything is cool with this now. So what I'm just going to do now is I'll go ahead and find each interior angle. That is, I'm looking for C. So I want to find C. So now each interior angle in a regular polygon is given by 180 n minus 2 times 180. That is the sum. But to get each interior angle, you divide it by n. So divided by n. Now, but this is a pentagon. A pentagon is 5-sided polygon. So that's 5 minus 2. That is 3. 3 times 180 divided by 5. So let's use a calculator to complete that. So 3 times 180 is 540. 540 divided by 5, and that is 108. So each interior angle of that regular polygon is 108. Now guys, there's no problem again. CC is 180, and if you look at this, let me change the color now to green. Now if you look at this now, CCA, oh, why am I doing this? Sorry about that. Okay, so this angle here, C plus A, is angle sum at a point. And angle sum at a point is 360. So C plus A, I'm looking for A. Sum up to what? 360. Reason, angle sum at a point. And C is 108. So 108 plus 108 plus A equals to 360. And then what I'm going to do now, I'll just use a subject of formula. So A will be 360 minus the sum of 108 and 108. So that is 108 plus 108. You can use your calculator to confirm that. That is 216. So minus 216. So A equals to 360 minus 216. So what is 360 minus 216? And that is 114. So angle A is 114. I think this is a very good method, guys. At this point now, I want to call it a day. This is the end of our tutorial on solving polygons. So I'm going to make more videos on these, guys. And before I leave now, let me quickly show you something, guys. Guys, I'm going to make more videos on the following or I have already. Then I'm going to make more also. Degree of accuracy calculus, turning point of quadratic graph, graph and calculus, cubic graph, matrices, addition and subtraction involving equation, multiplication, determinants, equation, transformation matrix, geometry, similarity and congruence of triangles, solving polygons, and circle geometry. So in circle geometry, I will be dealing with theorem 4b, 5c, and 6. So, and there are a lot of resources, guys, you can get here. Just type this address or your URL, and guys, access as many resources as possible. So guys, also do well to subscribe to my channel, please. Just click like or subscribe. Love you guys. Do have a great day ahead. Bye bye guys. Bye guys. Bye, have a nice day. Bye guys.